Indexing is handy when you know which part of the data you want. But what if you do not know in advance? Then you seriously need to take a look at masking. Let's begin with a simple example. Here, we first import pandas and numpy. Then we create a new series with numbers and an empty element. Here, again, we use np.nan to denote an empty element. Now, print and see. Great! So, the simplest Boolean mask is an evaluation of equality. If you simply go s equals 3, just run, you will see a series of Boolean values. Boolean values are values that can only take true or false. You see, only the second element is true, which is where we put the number 3. Other non-3 elements are set to false. If you understand this, then you already knew what masking is. Masking is simply selecting elements with a series of Boolean values. Imagine that you take our result from s == 3 and overlay it on our series S, just like a mask. And you check every value, keep only the values whose corresponding mask says true. Then you have completed a masking operation. Let me show you how it is done. So S brackets are for indexing, right? Guess what? It can also deal with Boolean values. So you just insert what you did in the brackets, s == 3, that's it. Run this cell, perfect. Now you might think selecting the element that equals 3 with a Boolean mask does not seem fantastically smart. Here's a few more tricks. Let's select all numbers larger than 5. You just do s bracket s larger than 5. Numbers larger than 5 but smaller than 7? Sure thing. You just go s bracket s larger than 5 and s smaller than 7. Here we need to use a pair of parentheses to force the logical order of evaluation. This makes sure that our larger than 5 and smaller than 7 conditions are evaluated before taking on the AND logic. Remember, you always need to do that when combining multiple conditions. Now, just run this. That's quite some work. The last thing I want you to know is how to find out the missing values. Very important stuff here. Remember, in the series we created, there was a missing value, represented by np.nan. Right. That's an exception I planted. To detect it, we can probably use the masking technique we just learned. Let's do that. S bracket s not equal np.nan. Run this. Something is wrong. It does not seem to work. This thing here, folks, this is an exception you need to keep in your mind. To find out missing values in pandas, you need to call the specialized pandas function. So the proper way to do it is like this. S bracket pd dot is null and put s as the parameter here. The function will find out the missing values for you. So just run. Excellent. How to select all non-missing values? That's right. You just invert the mask. Add S bracket tilde. Tilde means to invert the logic. So the true becomes false and the false becomes true. So tilde PD dot is null and put S as a parameter. That's it. Thanks for watching and see you in the next lecture.